If you don't get it right and you just start coding, you will lose money, you will waste time. Companies will crash because you claim to be a data scientist, but you don't even know how does AI learn? Like, really learn? Is it just memorizing data, or is there something deeper going on? Welcome back to the channel. My name is Prince. I have a bachelor's in statistics, a master's in data science, and years of experience in AI and published research. But don't worry about all that. I'm here to break it down in the simplest way possible for you. Before we even start training an AI model, we need the data. This data is usually stored in an Excel spreadsheet or any other spreadsheet. It's commonly called a data set. Each row represents like a specific example or observation. It's horizontal, while each a column represents a different type of information or what we call features. So for example, let's assume a data set of houses in your neighborhood. Each row will be different houses. Let's say your house, your favorite neighbor's house, and each column will things like color of the house, price of the house, for example, square footage, how many bathrooms. Those will be different columns or features about it. It's like each row is a unique case, while each column, the features, are information about the cases. Now that we have our data sets, I want to explain features and labels. Simply put, features are the data we want to use to make prediction, while the label is what we want to predict. Back to the house example. In the house, the label will most likely be the price of the house. We're trying to make an AI model that can predict the price of a house. Whatever it's predicting is the label. So what do we use to predict the price of the house? What data do we give the AI to predict the price of the house? It can be data like, what is the size of the house? What is the size of the land? What is number of bathrooms, number of bedrooms, the quality of the wood? You can add more features like the crime rate in the neighborhood, weather condition. Is there a lot of tsunami in the area? That might affect the price of the house. Those are all features. Another example, you are trying to make an AI model to predict between an adult or a child. The features can be how many years of work experience do they have? What is their height? I know there are some tall children and short adults, but generally adults tend to be taller than children less than 10. You can check how many countries they've traveled to. Just basically whatever you can add in that scenario, that will be the feature, because what you're trying to predict is the label. Now that you understand features and labels, let's go into how does this affect the machine learning? How does it learn with this? In the first video, AI 101, I said that machine learning AI is just basically how did I learn something? How did I learn to read the time? And we're trying to use that angle to try to teach a computer. When you're in school, or those of you that are still in school listening to this, you have tests and you have examinations. Some schools, they call exam tests and vice versa. But here it's called train test splits. Let's say you have a data of 1,000 houses in your neighborhood. You have to first divide the data set into two, called the training data and the testing data. The main idea here is that it learns on the training data. So you have to test it, same as when you're in school. When you finish your classes, they didn't really trust us, so we had to do tests and examinations to make sure that we weren't just, I don't know, playing around or writing letters to each other. Like in school, examination wasn't your whole 12 weeks in school, 14 weeks. Most of your time you are learning. So your training data is always bigger and then your testing data is small. Your test data is not the same questions in your training data set. So if you have 1,000 houses in your neighborhood, you're trying to train an AI, let's assume that the first 800, or however you split it, 800 random houses in your neighborhood will be used to train the AI model. And then you keep 200 behind that AI hasn't seen. It's the same example with a teacher will teach you, let's add and subtract. And in exam, you're getting algebra. And you're like, hey, sorry, you didn't teach us this. Exactly. We're doing that to AI now because we have the power to. It's kind of interesting that we can do that to someone else and they wouldn't really complain like human beings. Moving on, that is the main idea of train and test. So why we call it train test splits is because there's no size that you should divide for train and testing that is like gold standard written in gold. We all like 70-30% splits, which means 70% of your data is going towards training, 30% that it hasn't seen before, we go towards testing. But you can use 90-10% split, you can use 85%, 15% split. It all depends on whatever you want to do. I will go deeper into that in future videos. Let's assume that we just follow the generalized one, 70-30% splits. So you randomize it, pick 700 houses from your neighborhood. Is that information, you train it on your AI model. Then when it says that, yo, I'm done learning, you'll be like, yeah, it's time for exams now. Now, next question, why do we do that in the first place? I always wondered why my teachers didn't give us the same questions in class and give us an exam. It's simply to make sure that you are not memorizing. Some students, they know how to cram books. In practical life, everything may be different. Textbook will tell you this is how to do a backhand smash. This is how to smash forehand. I've seen people that smash like this, but I mean, it's still part of the rules. So you have to be prepared for the main event. That is why we test it. When it's done training and testing, it kind of gives you a result. When you were in school and you finish training and then they tested you in exam, what your parents want to look at, that you're scared to look at sometimes, will be your results. And your result, out of 100, you scored 80%. That is known as accuracy. There are a lot more evaluation metrics. That will be my next video. Let's use the house example because it seems like everything will just flow with the same house example. You carried 1,000 neighbors, you trained it on a random 700, you tested it on 800. You now want to know, is this thing right? Let's say my favorite neighbor, his house is 200k USD and my AI predicted is 220,000 USD. How do we know how good it is? We'll just simply look at the difference. It was $20,000 off. That may not be a bad prediction. Each one of that will not be an accuracy. In the previous example, is it an adult? Is that a child? If the AI guesses that the person is a child when it's an adult, that is wrong. That will be using things like accuracy because that's a classification problem. That's how the result should look like. So now, based on the results, you can choose, hey, do I want to push this to public, to production, or do I want to retrain the AI? There's a lot of things that go into that, and I will go further into that in future videos. But that is just how to train a model, basically. I'm going to talk about two main types of machine learning problems. There's the regression type problem and the classification type problem. Now, I don't want you to mix up these two with supervised, unsupervised, and reinforcement learning. Those were the types of machine learning. I'm going to link the video here so that everyone follows along. Going into classification problem, it has to do with the example of you're trying to predict between an adult and a child. Basically, it looks through the data and tries to find patterns to try to separate and classify data points or the labels into different categories. Simply put, it's trying to say, hey, are you an adult? Are you a child in the example? That is a classification problem, not numbers. Let's look at examples of this. Companies may use this kind of machine learning approach. The problem will be you enter into their store and they're trying to predict, will this particular customer, that is you they are referring to, will you buy or will you leave? What are the chances you're going to buy? That will be a classification problem based on everything. If I walk into a store with Barbie dolls, what are the odds that I will buy something? And you see another man that is walking there with his daughter, she's pointing everywhere. And we have one customer service representative. You would like to go towards the man with the kid because there's a very high chance that they are going to buy something. That is a classification problem. Will rain fall tomorrow or will it not fall tomorrow? That is a classification problem. Then the regression problem. This is when we're predicting a continuous number instead of a category. If you are trying to predict whether the house in your neighborhood, if it's expensive or cheap by whatever metric, that will be a classification problem because it's divided in classes. But if you are trying to predict the price of a house, you see that's a continuous variable. How many categories are there for price? Is 0 to infinite. That is a regression problem. Price of stock is a regression problem. But if you frame the question, will stock go up or down? That is a classification problem. The way the problem is determines how we are going to solve it because AI is that logical. So how do computers learn regression? It's trained on past data. It can look at the historical prices of houses in your neighborhood or historical price of stock. I know a lot of people are interested in this, in Bitcoin and all that. If it's true, you can predict it. What big firms may be doing, because everything is in secret, is they have historical data on that. So if they want to know, okay, is JP Morgan going to go up next quarter, they may look at historical data on that. Okay, what was inflation rate by this time, this particular quarter, and what did JP Morgan do for the last 50 years? Like what their stock price do. They just keep on asking more questions, but the way they framed it, if it's will it go up or down, that is a classification problem. If it is, let us predict this price of JP Morgan stock, it is a regression problem. Examples of regression problem, you must have heard them before. That's where you hear linear regression, decision trees, all those, they are regression problems. In a simple phrase, regression is all about predicting a number, or you can say a continuous number, based on patterns or variables in the data. With the example of height, is someone tall, are they short? That is a classification problem. But if you say, what is my height? I'm 6 watts. I'm 6 watts. That is a regression problem. At this foundation level, if you don't get it right and you just start coding, you will lose money, you will waste time, companies will crash because of you claim to be a data scientist, but you don't even know these kind of things. It's so simple to misframe. In statistics, if you don't know if something is a Poisson distribution or a normal distribution or a binomial distribution, and you kind of mix it up, you have already filled the question before you started. Maybe your lecturer will give you half mark for each particular formula you get right, but you are going to get something like 4/64. This is from a past history in my life. That's why I'm pondering on this particular point. Is very, 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 very serious to remember. In one phrase, what are the main differences between classification and regression problems? Classification predicts categories, while regression predicts numbers. Next time when you look at your phone and you see something that seems like an AI problem, ask yourself, is this a regression problem? Is a classification problem? That will lead me to the fun challenge of this lesson. Email spam detection. Is it classification or is it regression? And the second part of it is kind of the tricky part. But now that you know whether it's classification or regression, is it a supervised problem? Is it an unsupervised learning problem? Is it a regression learning? What do you think it will be? In order to answer this question, you must have watched my first video, AI 101. Please leave your comments. I would like to answer. I will expect an answer and why you think is an answer. That way I can go back and forth and try to correct it if there's something you miss out. In conclusion, we learned the data comes in the form of a spreadsheet. We learned about the rows. The rows are for each observation. The columns are for the features. We learned about training and testing splits. We learned the results. How do they look like? That's where accuracy, error terms. We also learned the classification and regression type problems. And in the next video, I'm going to go further into the evaluation metrics for both regression and classification. We'll answer questions like, how do they know ChatGPT is better than DeepSeek, for example, or vice versa? How do they test it? How do they know that? If you have listened up to now, I really appreciate the love. Thank you so much for all this. So if you enjoyed the video up to now, like this video so it can go up in the algorithm so more people can learn about this. Share it to your friend that is really interested in things like this, and leave a comment so that I can see your journey and how much you understand.